Now we can study the next colligative property, that is osmotic pressure. Before studying osmotic pressure, let us study what is osmosis. Osmosis means if a solvent and solution are separated by a semi-permeable membrane, the solvent molecules will flow through the membrane from pure solvent to solution. This process of flow of solvent is called osmosis. That is, here in this a solvent, and this is a semi-permeable membrane. Semi-permeable membrane means it pass only the small solvent particles. Small solvent particles only allowed to pass through it solvent particles because small size. And such membranes are called semi-permeable membrane. The membrane which allowed to pass only solvent particles are called semi-permeable membrane. Example, cellulose. Cellulose is a semi-permeable membrane. Egg membrane. Egg membrane is an example of a semi-permeable. An artificial copper ferrocyanide is also a semi-permeable. So, when a solvent and solution inside this thistle funnel, solution, it is suppose it is sugar solution. That is, when we take some solution inside this thistle funnel and close the mouth of thistle funnel with a semi-permeable membrane or egg membrane, then we keep this arrangement in a solvent, that is pure water. We can see that the level of water in this solution, the level in this thistle funnel increases. That is, the solvent molecules pass through this semi-permeable membrane inside the solution. Only solvent molecules pass through this membrane. So that process is called osmosis. So osmosis is when a solvent and a solution are separated by a semi-permeable membrane, that membrane allowed to pass only solvent molecules. As a result, the height of this solution increases. At that is osmosis. During osmosis, to stop the osmosis, we have to apply some pressure here. That pressure, that is the excess pressure required to just prevent osmosis, is called osmotic pressure. That is, pressure during osmosis is called osmotic pressure. Or we can say the extra pressure, excess pressure required to just prevent osmosis is called osmotic pressure. Osmotic pressure. What is osmotic pressure? It is the excess pressure required to just prevent the osmosis. Now, during this osmosis, a pressure is developed or pressure is required to prevent osmosis. That is called osmotic pressure. Now, this osmotic pressure is directly proportional to concentration, and it is also directly proportional to temperature. Osmotic pressure pi is proportional to C, it is proportional to T. So we can write pi is proportional to Ct. Pi is proportional to Ct. But pi is proportional to C is number of moles by volume, N by V into T. The C is equal to concentration. Concentration is number of moles by V. So we can write pi is proportional to N by V into T, where pi is osmotic pressure, N is the number of moles of solute, V is the volume of the solution, T is the temperature. So we can write pi V is proportional to Nt. Pi V is proportional to Nt, but N is equal to mass by molar mass. N is equal to mass by molar mass. N is equal to mass by molar mass. So we can write pi V is equal to W by M into the proportional, but this proportional can be changed by using an equation. Pi V is equal to a constant R into W by M into T, where the constant R is called the solution constant. R is called the solution constant. R solution constant. We studied R as a gas constant. In this case, R is a solution constant. R is a gas constant. In states of matter, gaseous state, in gas laws, we studied R as a gas constant. Here it is a solution constant. So we can write pi V is equal to R into W by M into T, or pi is equal to mb. On rearranging this m we get w into RT by pi. M come here and pi we come here. That is, this is equation. Molar mass is equal to W into RT. Here it is WB because it is solute. WB means solute. Solute into solution constant into temperature divided pi into B. Here OB is in liter. This is the relation between molar. So molar mass and vapor pressure. Molar mass is equal to mass of solute into solution constant into temperature divided by osmotic pressure into volume in liter. Here R has the same value, 0.0821 liter atmosphere per Kelvin per mole. This is a molar mass and osmotic pressure. Now, if two solutions have same osmotic pressure, then such solutions are called isotonic solutions. If two solutions have same osmotic pressure, then such solution, two osmotic solutions are having same osmotic pressure are separated by a semi-permeable membrane. That is, they will not flow. There is no change. That is, pi 1 is equal to pi 2. Osmotic pressure of the first solution is equal to second solution. So N1 is equal to N2. Number of moles in two cases is the same. So we can write W1 by M1 is equal to W2 by M2. This is the equation of osmotic isotonic solution. Iso means the same. Isotonic solution means the same osmotic pressure. For isotonic solutions, W1 by M1 is equal to W2 by M2. So if between two solutions, solutions having higher osmotic pressure is called hypertonic solution. And having lower osmotic pressure is called a hypotonic. So isotonic solutions, hypertonic solution, hypotonic solution. Isotonic means the same osmotic pressure, hyper high osmotic pressure, hypo low osmotic pressure. Now this is osmosis. Now we can apply pressure greater than. We can apply pressure larger than osmotic pressure, then the direction of osmosis is reversed. This is fresh water, this is salt water. This is solution, this is solution, this is a solvent. Usually when solvent molecules pass from solvent into solution, but when a pressure greater than osmotic pressure is applied, here we are applying a pressure greater than osmotic pressure, then the direction of movement will be in opposite direction. That is the direction. This direction can be changed to this direction. That is called a reverse osmosis. So reverse osmosis means when a pressure greater than osmotic pressure is applied, the direction of the movement can be changed. That is called a reverse osmosis. Here, reverse osmosis is used in desalination of water. Desalination means this is seawater, this is seawater. This is fresh water, then the seawater. From seawater, the pure water flow to this direction. This is desalination. So, reverse osmosis, application of the reverse osmosis is desalination of seawater. Seawater can be, from seawater, pure water can be separated by this reverse osmosis. Now, abnormal molecular mass. Abnormal molecular mass. When we determine the colligative property, we determine the molar mass of a certain substances by using colligative property methods. That will be higher or lower than the actual value. Instead of getting the correct value, we will get a higher value or lower value. This is called an abnormal molecular mass. This abnormal molecular mass is due to two reasons. One is due to association, or it may be due to dissociation. If association takes place, then what happens? The molecular mass increases. When association, for example, this is acetic acid. Acetic acid undergoes a dimerization in benzene solution. Dimer means two units combined together. Dimerization. Acetic acid undergoes dimerization in benzene solution. So, if we determine molar mass by colligative property method, we will get 120 instead of 60. That is 60 is 2 into 2 is equal to 120. This is called abnormality. So dimerization takes place, double of molar mass is obtained. But if dissociation takes place, molecular mass will be lower, molecular mass decreases. For example, KCl in water dissociates, undergoes dissociation, K plus Cl minus. Now the particles be increased, but molar mass becomes lower, molar mass lower. This is called abnormal molecular mass. That is a colligative property methods, molecular mass determination give a lower or higher value, that is called abnormal molar mass. It is due to if association takes place, we will get higher molar mass. If dissociation takes place, we will get lower molar mass. Now, to explain this abnormality, scientist namely Van Hoff suggested a factor that is called Van Hoff's factor. Van Hoff's factor, that is I is equal to normal molar mass by abnormal molar mass. In the case of acetic acid, normal mass is 16, but we are getting 120. That is 1 by 2. 1 by 2 or 0.5 is the Van Hoff factor of acetic acid. Then 1 by 2 means dimerization. If dimerization, that is 1 by 2 is Van Hoff factor. If a trimerization, trimerization 1 by 3. 1 by 3. If a S8, octamerization, what is 1 by 8? That is, if association takes place, reverse. If a dimerization 1 by 2, trimerization 1 by 3, octamerization 1 by 8. That is abnormal molecular mass. And if it is less than, potassium in the case of KCl, it divides into 2, K plus Cl minus. So that is particles, 2 particles. So lower molecular mass. So here Van Hoff factor is equal to 2. If Van Hoff factor is equal to 1, if normal molar mass and abnormal molar mass are same, there is neither association nor dissociation. If I is greater than 1, dissociation. If I is greater than 1, as in the case of KCl, divide into 2 particles. In the case of FeCl3, 3 plus 1, 4 particles. That is Van Hoff factor is equal to 4. That is, if I is greater than 1, dissociation. If I is less than 1, association. I is greater than 1, association. That is Van Hoff factor. Now, by introducing this to remove the abnormality, we can multiply each equation with the Van Hoff factor. So, by inclusion of Van Hoff factor modifies the equation, lowering a vapor pressure equation as we are multiplying with I. P0A minus PS by P0 is equal to I into NB by NA. Or delta TB is equal to I into KB by M. That is elevation of boiling point, delta TB is equal to I into KB into M. Depression of freezing point, delta TF is equal to I into KF into M. And osmotic pressure equation, pi is equal to I into NB RT by V. This is Van Hoff factor. That's about this. Thank you.